Hello everyone and welcome to C3 Streamland. So in the last video we saw three different types of quadrilaterals and their properties. So we saw talked about square, rectangle and rhombus, and at the end of the video I asked you a question um, that why square and rhombus, since they look so similar, it's just that square being turned 90 degrees and that looks like rhombus, why they are called two different shapes. So I hope you found an answer for that. But if not, then pay attention because I'm about to tell you. There is a very small, minor flexibility that rhombus shape can have, which square doesn't have. So basically, if you want to make a square, you're supposed to have all sides equal, opposite sides parallel, and all the angles must be 90 degree. In rhombus, you should have, you can have all sides equal, right? You can have opposite sides parallel, but the third condition where all angles should be 90 degree, that is a little bit flexible. So basically, as you can see here in this rhombus, all the angles are 90 degrees, internal angles, but I can also make a rhombus like this and this will still be a rhombus, right? So in this case, my opposite sides are parallel. One of my angle is probably 90 degrees, but not necessarily, right? And some angles can be obtuse also, right? This is basically a kite. So yeah, so that is one small flexibility that rhombuses can have, which we don't have in squares. That's why we need to have this segregation between square and a rhombus. Now moving on to next type of quadrilaterals, let me go back to my polygon tool. So till now we dealt with quadrilaterals which have 90 degrees angles. But what if I don't want to have 90-degree angle? Can't I create a quadrilateral? Of course you can. As long as the opposite sides are parallel, we can create different types of quadrilaterals. Now in this case, this particular shape is called parallelogram. The reason it is called parallelogram is because the opposite sides are parallel to each other. But if you pay attention to the angles are definitely not 90 degrees. In fact, if you want to see, two of them are obtuse angles and two of them are acute angles. The only thing is that only condition for it to qualify as a parallelogram is if these two opposite angles are of the same measure, right? So since I'm doing the external angles, let me see if at least external angles should be exactly same in these two. Okay, we took one external and one internal. Very nice. Okay, I can quickly move it by clicking on this tool and then go to angles, make it 0 to, and as you can see, the opposite angles are exactly the same. And that should also be true for angle MNO and MPO. And in that case, if that is the case, then this shape can be qualified as a parallelogram. Now what if I want to create a quadrilateral which doesn't have necessarily all the four sides parallel? Of course you can create a quadrilateral like that. So let's try. So I want one vertex to be here, another to be here, one to be here, and another to be here. Now this particular shape is called trapezoid. Now in this case, two of the sides are parallel. So at least we try to keep two sides parallel, right? For trapezoid, the rest of the two sides, they don't have to be parallel, right? They can be non-parallel, right? But then what about angles? So as you can see here, these two angles, angle RQT and angle QTS, are obtuse angles, and rest of the two angles which are making it R and S are acute angles. Now if I add angle R and Q, the addition or the sum should be 180 degrees. Same for T and S. If that is the case, then this particular quadrilateral can be qualified as a trapezoid, right? So these are different types of quadrilaterals. You can also create more than this based on, you can bend the rules and you can create any type of polygon. So basically any polygon which is enclosed space, right? uh, and has four sides, four corners and four angles can be a quadrilateral. But there are some significant quadrilaterals square, rectangle, rhombus, parallelogram, and trapezoid. And there are the properties which are for that particular type of quadrilateral. Okay, you can also have a quadrilateral which is something like this. This will also be qualified as a quadrilateral, but it will be none of these, right? It's just a quadrilateral. We can talk about this later at length, this particular shape, but for now, this is for the properties of different types of quadrilaterals. And happy exploring.